In this video, I will introduce a new way of performing a calculation called dimensional analysis. This is a technique often used by chemists to convert numbers that have one unit into numbers with another unit. To show you how this works, we will do an example using the AM6000 concept. Our example problem is, using the AM6000 concept, how many molecules are there in 4 grams of copper sulfate? Because we are using the AM6000 concept, we need to start with a number that comes from the periodic table. The first step is to figure out the mass of copper sulfate, which is 160 grams. Because this is a number straight from the periodic table, we know it has to be over 6,000 molecules. The next step is to set it equal to another fraction, and this is where we put in the 4 grams of copper sulfate we were given. This goes on top because grams are on top on the left side as well. On the bottom, we will have our variable x, because this is what we are looking for. We are trying to figure out how many molecules there are in a 4-gram sample of copper sulfate. The next step is to cross-multiply. When you do this, you should get 160x is equal to 4 times 6,000. Multiplying across, we get 160x is equal to 24,000. And finally, dividing by 160 on both sides will tell us that x is equal to 150 molecules of copper sulfate. We will now solve the same problem using dimensional analysis. When we do a dimensional analysis problem, we will start with what we are given and then multiply that by a conversion factor. So for this problem, what we were given was 4 grams of copper sulfate. So that is what I will write first. Then I need to set up a conversion factor that I will multiply that by. The key to dimensional analysis is that we want our units to cancel. Because the number I'm given has the unit of grams, I'm going to put grams on the bottom of the conversion factor. Because we're using the AM6000 concept, I know I can put molecules above that. And again, in the AM6000 concept, we have 6,000 molecules, and from the periodic table, we have 160 grams of copper sulfate. Because we have grams on top and now grams on the bottom, I can actually cancel out those units, and all that's left is molecules. We now multiply across what's on the top and divide what's on the bottom. So we have 4 times 6,000 divided by 160, and we are left with 150 molecules of copper sulfate. Molecules did not cancel, so those are still our units. And as you can see, we get the same answer both ways. This problem reads, a football field is 100 yards long. How long is that in inches? So, in this question, we are converting between yards and inches. A useful first step is to figure out what the conversion factors will be. The first one will have to be between yards and feet. In 1 yard, there are 3 feet, so I can write this conversion factor as 1 yard over 3 feet. The next conversion factor will be between feet and inches. There are 12 inches in 1 foot, so I can write the conversion factor as 12 inches over 1 foot. Something important to know about conversion factors, though, is that they can be written either direction. You could have one on the top and the other on the bottom, or vice versa. So I could also write that for 1 foot, there is 12 inches. 1 foot over 12 inches. So for this problem, you will need 2 conversion factors. One that converts between yards and feet, and another that converts between feet and inches. So, as before, we will start with what we were given, and then multiply that by both conversion factors. For this problem, we were given 100 yards, and I will multiply that by 3 feet over 1 yard. I decided to write this conversion factor that way so that yards would be on the bottom in the conversion factor. This means that I can cancel those units later on. For the next conversion factor, I will write 12 inches over 1 foot. Again, I'm writing it this way so I can cancel out feet on the top with the feet on the bottom. So once I have this all laid out, I will go through and cancel out all the units. And if you've done this correctly, the only unit left over should be inches. We will now multiply across, so we get 100 times 3 times 12, and that is equal to 3,600 inches. That is the number of inches in a football field.